The Pacific breeze off the California coast carries the promise of something extraordinary. Tonight, a rocket stands ready, a silent sentinel against the twilight sky. Its engines will soon roar to life. The sky will ignite, and high above our world, dozens of small satellites will be released, silent, swift, and inexorable. This isn't just another launch. This is a mission that perfectly captures our modern era: connectivity, reusability, and boundless ambition. From the rugged western shores of the United States, a Falcon 9 rocket is about to rise. From its upper stage, 28 Starlink broadband satellites will spiral into low Earth orbit. But what goes up in this case comes back down. The first stage booster will return to Earth not to be lost to the ocean, but to land with pinpoint precision on a floating platform out in the Pacific. Reuse is the new frontier, and tonight, the sky becomes a stage where engineering, commerce, and a bold vision all converge. The launch took place from Vandenberg Space Force Base in California. It's a facility perched right on the coast, a perfect location for rockets to fly southward over the Pacific, enabling missions into high-inclination or polar orbits with minimal risk to populated areas. On October 27, 2025, at approximately 5:43 p.m. local time, the Falcon 9 rocket lifted off, carrying its precious cargo of 28 Starlink satellites. To put this into perspective, SpaceX has been relentlessly building its Starlink mega constellation. We're talking about tens of thousands of small satellites in low Earth orbit, all designed to beam high-speed internet to every corner of the globe. By the time of this mission, the company had already launched over 10,000 Starlink spacecraft, with nearly 8,750 of them actively serving users. This specific launch also marks SpaceX's 137th Falcon 9 mission of the year, an absolutely record-shattering pace. The booster used for this flight, designated B1082, was making its 17th trip to space and back. Think about that for a moment. 17. This mission perfectly highlights the two signature pillars of SpaceX's strategy: rapid satellite deployment and fully reusable rocketry. On one hand, launching a batch of 28 satellites adds crucial capacity and coverage to the Starlink network. On the other, landing the booster turns what was once a disposable, multi-million-dollar piece of hardware into a routinely reused asset like an airplane. As the sun dipped toward the horizon, the teams at Vandenberg were in the final stages of preparation. The sleek, black-and-white Falcon 9 stood poised on the launch pad. Ground crews conducted their final walkdowns, ensuring every connection was secure. The weather was monitored constantly: the coastal marine layer, wind shear, and even the sea state at the distant landing zone were all critical factors. Inside the control room, technicians methodically ran through checklist after checklist: propellant loading, engine chill down, telemetry links, range safety clearances, and tracking the drone ship. Every single system was brought online, and every parameter was verified. Launch windows for these missions can open and close in a heartbeat if conditions fluctuate. But for this flight, everything was nominal. The mission, sometimes called Starlink Group 11 to 21, was a go. The satellites on board were the V2 Mini, variant smaller, mass-optimized craft designed for high-density deployment. Meanwhile, far out in the Pacific, the drone ship, Of Course I Still Love You, was holding its position, waiting for its catch. The plan was textbook SpaceX. After separating from the upper stage, the booster would execute a flip maneuver, reignite its engines to slow down, steer itself through the atmosphere, and land upright on that floating platform, all in about 8.5 minutes. And then it happens. The engines ignite with a deep, resonant rumble that you can feel in your chest. The launch pad is flooded with brilliant light. The hold-down clamps release, and the rocket gracefully lifts clear of the tower, ascending into a clear patch of evening sky. A black plume of smoke marks its path against the Pacific twilight. The rocket pitches downrange, accelerating with incredible force. As it climbs over the ocean, the aerodynamic stress on the vehicle peaks. Everything on board must perform perfectly. At approximately 2 minutes and 30 seconds into the flight, the first stage engines cut off and it separates from the second stage. The upper stage's single engine ignites, continuing its journey into orbit, while the first stage begins its spectacular return sequence. The booster executes its re-entry and landing burns, flipping itself around to face the direction of travel. Meanwhile, the upper stage continues its climb into a temporary parking orbit. And back in the dark waters of the Pacific, the drone ship waits. Its thrusters hold it steady against the ocean currents. The incoming booster approaches at supersonic speeds, precisely aligning itself, deploying its landing legs, and touching down perfectly upright on the moving deck. It's a sight that's no longer novel as expected, but every single landing is a high-stakes maneuver. A successful touchdown means another reuse, another mission. Tonight, the booster stuck the landing, another demonstration of incredible reliability. With each successful landing, SpaceX moves closer to its goal of making space access routine, cost-effective, and rapid. Reusing the first stage dramatically lowers the cost per kilogram delivered to orbit and enables this incredible launch cadence. High above the Earth, about an hour after liftoff, the upper stage reached its deployment altitude. The 28 Starlink satellites, tucked safely inside the payload fairing, were released one by one into the cold void of space. Then began their silent ballet, orbit tracing, deploying antennas, unfurling solar arrays, and integrating with the vast network already in place. Each small spacecraft joins a mesh of thousands of nodes orbiting the Earth, beaming internet signals down to remote communities, ships at sea, and planes in flight. The hardware is small, but the ambition is truly global. At first glance, this was just one more rocket launch, one more batch of satellites, one more booster landing. But if you dig deeper, you see a transformation happening in real time. This is about global connectivity. It's about ceasing to think of space as some unreachable final frontier, and instead seeing it as critical infrastructure. Just as electricity transformed our cities, broadband from space has the potential to transform our world. This is about turning single-use rockets into a fleet of reusable flyers. For SpaceX to launch 137 times in a single year means what used to be exceptional is now simply expected. That shift is seismic. This mission is only one step in a much larger journey. Tens of thousands more satellites are planned. Turnaround times for boosters will shrink even further. New services for maritime, aviation, and rural broadband will expand. Of course, challenges remain. Orbital debris, international coordination, and long-term sustainability are all serious issues that need to be addressed. The sky is getting crowded. But each challenge that is solved brings humanity closer to a new normal. Imagine a remote mountain village once completely isolated, now connected. Students attending virtual classes with teachers from around the world. Doctors consulting with patients thousands of miles away. This is more than just technology. It's empowerment. SpaceX's Starlink network is actively bridging the digital divide, turning once isolated regions into active participants in the global conversation. So let's zoom back to that moment of launch. The countdown hits T0, the engines ignite, the rocket arcs skyward, and the coast vibrates with its power. 8 minutes later, a booster lands on a ship far out at sea. And high in orbit, 28 new satellites begin their silent, vital work. What once seemed like science fiction is now a repeatable, almost routine, process. This mission teaches us that our access to space is evolving from rare to routine, from singular to scalable. As the night deepens and the booster rests on its floating platform, these 28 new nodes in a global network embark on their silent orbits, circling our planet every 90 minutes. This mission ends with a successful landing and deployment, but in truth, it's just the beginning. The sky above is no longer a limit. It's a conduit. Tonight, as the Pacific horizon fades into starlight, we witnessed another piece of tomorrow taking shape, right before our very eyes. Thanks for joining me on this incredible journey. If you found this as fascinating as I do, be sure to hit that like button, subscribe, and ring the bell so you don't miss our next deep dive into the future of space exploration. See you next time.